Good morning, dear students. Last class I have given important basic concepts of analytical geometry. At the same time, I have given information about rectangular Cartesian coordinate system in the plane also. At the same time, how to find out distance, how we are going to take the distance from the point to coordinate axis. About this also I told. At the same time, I have given information about the reflections and images, if reflections or images also. Today also we are going to solving problems on images. At the same time, I'll tell you one important theorem, that is the distance between the 2 points form theorem. Now let us, we are going to find images, how we are going to taking images from point to 2 in the coordinate axis. Let us now, we are going to solving problems on images. First one is find the image of the points, image of the points. Find the image of the point P 2, 5 in x-axis, and y-axis. Already I told also, when they will ask like all these questions, first must and should draw a diagram. By taking the diagram easily we can analyze here. Same means I will show you now. P is equal to 3. Let us now, we are going to starting the solution for this question. Here P is there, y-axis, and now here x-axis here. Point is there. Now first you must observe that the point P 2, 5 is the plus 2, plus 5. We can observe the symbols here. Plus plus has K means that point lies in a first quadrant. Here first quadrant will come here. Plus 2, 5 here. See, approximately. Its images in x-axis are asking now. Just draw one perpendicular line, x-axis line. The line moves into fourth quadrant. It's the first quadrant, and second quadrant, and last one is the third quadrant here. Last one is the fourth. Y move y dash here. Yes, it is. X dash here. The point moves. They're asking image of the point to go in x-axis moves downside here. It moves downside means it moves into fourth quadrant. In fourth quadrant symbols are generally plus comma minus, that is 2 comma minus 5 is the image of the point P 2 5 in the x-axis. Similarly, in the same way, they are asking in y-axis. Say here, it is this side. Draw the line, second quadrant side. Here the point image they are asking, that is a cube minus 2 comma plus 5. Otherwise, if they can ask with respect to origin means from the point P to move down here. If we can down means here the point will come minus 2 to minus 5 like this. But they did not ask here in this question. If they can ask at the time with respect to origin, if they can ask at the time, we can draw the third quadrant symbols. Next, let us now, we are going to solving another question with in case of images and reflections. Images or reflections, both are giving same in here. Find the image of the points. Second question. Find the images. Find the images of the point points P minus 5 comma 9 in x-axis comma in y-axis and with respect to origin and with respect to origin they're asking three questions here. They're asking three questions in x-axis, in y-axis, at the same time with respect to origin also here. See here. Solution to this question is, now by taking one diagram here, x-axis and y-axis, it is the y-axis and it is the x-axis here, y dash, x dash here, origin this is. Minus 5 comma 9. Minus 5 comma 9 means generally minus comma plus here. It lies in second quadrant. Here they take a point P here. P is minus 2 comma 5 here like this. First one is in x-axis. In x-axis means down we can draw the perpendicular line. Here it will come. Here some q. Opposite to that we can write minus 2 comma minus 5 because in third quadrant symbols are minus comma minus. At the same time they are asking in y-axis. In y-axis means y-axis side we are going to drawing a perpendicular line from P onto the first quadrant here. Here q is yes, we can represent here. Then the point becomes here 2 comma 5. At the same time, with respect to origin, they are asking with respect to origin means we can represent the dots. Here the line will come here. Here or is 2 comma minus 5 like this. Like that, we are representing that images with respect to one point in x-axis, y-axis. At the same time, with respect to origin also we found here. That's why image of the point minus 2 comma 5 in x-axis minus 2 comma minus 5. You can write out no problem. Image of the point, image or reflection both are same. Image or reflection of the points. Image or reflection of the points of the point P minus 2 comma 5. Point P minus 2 comma 5 in x-axis. In x-axis is Q minus 2 comma minus 5 here. First point. Second point is the image of the point. Image of the point. Image of the point P minus 2 comma 5. Minus 2 comma 5 in the y-axis. In the y-axis. In the y-axis is yes 2 comma 5. Similarly, we can write here third point for this is here I am going to write the third point. Here I am going third point here. The image of the point. The image of the point. The image of the point P minus 2 comma 5 with respect to origin, with respect to origin is, with respect to origin is or capital or 2 comma minus 1. Like that, after drawing the diagram, after representing the image of the point in the coordinate system, then you should write some words also here. With the help of words, we are going to giving answer to these two, like all these questions. Like that, we are finding images. That's why I did two only. Similar to that, you can solve so many problems at your home. Simple. Already I give formulas. No, just you have to apply those formulas. Just take help from those formulas. Easily we can write images of any point from any quadrant to any quadrants. Like that, you have to apply procedure to find images in procedure to find images or reflections in analytical geometry. Now let us we are going discussing about how we are taking distance between the 2 points. At the same time, I'll tell you theorem on that formula. To find distance between the 2 points, to find distance between the distance between the 2 points, between the 2 points P, capital letter P, x1 comma y1, and Q, x2 comma y2, x2 comma y2 here. How we are going to finding the distance between the 2 points here? The distance between the 2 points means the formula is, finally you should get this formula. PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This formula we should get finally here. Now we are going to giving a proof to that formula, that PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square here. See here. First, in case of proof, let us we are going to start in the proof for this proof theorem. Before the proof, just first we must should draw a diagram here. Y-axis and this x-axis, this is y dash. Here you can represent this is x dash. Here take one line segment here. Here P is x comma y, x1 comma y1, and here Q is x2 comma y2. Just join the line segment P and Q here. perpendiculars from the points P and Q onto the x-axis. So PM is one perpendicular line here, PM, and QN is one perpendicular line here. It is one PM. It is also QN is like this, perpendicular QN. And also draw the one more perpendicular line PR. PR is one more perpendicular line here from the point P onto the line QN. Already I told also in the basics of analytical geometry, if any point Px comma y means in that point x comma y, the first coordinate belonging to horizontal line, second coordinate y is belonging to vertical line. Because already I mentioned also in the basics of analytical geometry, all the distances are measured from origin only to any points. That's what here, if you can observe the point to be x1 comma y1, that x1 is belonging to OM. x1 is belonging to OM. And PM is belonging to y1, like this. x1, fg is belonging to horizontal line and ordinate belonging to y vertical line. Similarly, the same way, that point q x2 comma y2 also. For that also, the distance of that point is measuring from origin only. That's what for the point q x2 comma y2 we can write x2 is belonging to ON. It is x2. Up to is x2, it is belonging to ON only. That is the ON. And last, y2 is belonging to belonging to vertical line here, like this, here from up to this, like this. That's what easily we can tell. Total distance ON and OM distance x1 in Mn becomes x2 minus x1 we can write here. Mn is equal to PR. It is a P here. This is the P here. Is the point P here. This is the point P here. You can represent like this. It is also x2 minus x1. Next, total distance Qn is y2 and remaining here PM distance y1. Then Rn also becomes y1 here. It is the Rn distance. Next, total distance y2 and remaining distance y1, then QR distance can be written as total minus remaining distance y1, that is y2 minus y1 can be written as QR. Like that, we are going to taking points here. First, let the line segment join the 2 points. Let the line segment joining of the 2 points, joining of the 2 points P x1 comma y1 and Q x2 comma y2 and Q x2 comma y2. Draw the perpendiculars. Draw the perpendiculars. Draw the perpendiculars. PM and QN from the points P and Q onto the x-axis respectively, onto the x-axis respectively. Next is and also draw the perpendicular and also draw the perpendicular and also draw the perpendicular PR from the point P onto the line onto the line QN here. If we can draw the perpendicular like that, then we are seeing the right angle triangle PQR. Without drawing perpendicular PR, how can you analyze that triangle PQR here? That's what we mustn't should mention like all these words. In geometry, it is in the case of analytical geometry, after taking the diagram, we should write about the diagram words. If you can't write, means you are not getting a full marks here. Directly we can write calculation, but it's not important here. You are going to diagram means we must should write some words about diagram now, and after that the better move to give solution about that. Now over all the words are over about this. Next, let us we are going to solving cell calculation parts. At the same time, from this diagram we can take from the diagram or from the figure. From the diagram, we can take PR is equal to Mn, and one more is PM is equal to Rn. PM is equal to Rn. Like that, we must take here. PR is equal to Mn means instead of Mn also we can take PR. That's what we can tell. We can take PR is equal to the diagram x2 minus x1 have taken. PM is equal to Rn. That's why here Rn place we can take y1. Right? We must mention about that also. Then this much theoretical part for this diagram. Because we can draw, already we draw the diagram. About the diagram we mentioned about all these statements and about all these about the diagram, all these words that are belonging to about the diagram only here. Now let us, we are going to taking a calculation part. Calculation part means very simple. Just if you can observe this diagram, there where you are seeing one right angle triangle. In analytical geometry, wherever, in case of trigonometry or in case of analytical geometry, wherever if you can hurt, if you can see about right angle triangle means directly you are going to remembering about the statement of Pythagoras theorem. That's what here the calculation part means. We mustn't should apply that statement of Pythagoras theorem now. Now let us, we are going to giving calculation part for this theorem now. In that calculation part or after completion of calculation part, finally we should get that formula PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let us, we are going to starting the solution part of this theorem. Consider from right angle triangle, that's right angle triangle symbol PQR we can write. Triangle PQR we can write PQ square is equal to PR square plus QR square. QR square. PR square plus PQ square is equal to PR square plus QR square. That is PQ is equal to here. PQ is equal to here. PR means what we have in the diagram? X2 minus x1 whole square plus QR means what we have in the diagram? Y2 minus y1 whole square here. That's what. Finally, we can write here PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance between the 2 points formula. How I have taken this formula means PQ PR square plus QR square is, according to the statement of Pythagoras theorem, we can tell the square of hypotenuse is equal to the sum of squares of remaining two sides in right angle triangle. That is, the hypotenuse square is equal to adjacent square plus opposite square. That is, the square of hypotenuse is equal to square of adjacent side plus square of opposite side. Like that, we are going to taking in case of right angle triangle with the help of the statement of Pythagoras theorem. With the help of that, finally we got the distance to the 2 points. PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Under this, we can give one important note here. The distance of a point, the distance of a point, the distance of a point Px comma y from the origin O0 comma 0 is always in the form of OP is equal to square root of x square plus y square. X square plus y square. Like that, distance of any point from the origin, rightly, square of first coordinate plus square of second coordinate. That formula we are going to applying distance of any point from the origin. Now I am going to giving some important basic concepts formula under the note of this analytical geometry. Let us now, I am going to giving some important formula in case of section. When the point divides line segment, how we are going to find the coordinates of that points. At the same time, what are the conditions to show the collinear points with respect to distance? I will tell you about all this now. And this note first. Number 1. The coordinates of division points the coordinates of division points. Division points, comma, which divides the line segments, which divides the line segments PQ, which divides the line segment PQ in the ratio PQ in the ratio M is to N, M is to N, internally or given by or is equal to mx2 plus nx1 whole dividing by mx2 plus nx1 whole dividing by m plus n, comma, my2 plus ny1 whole dividing by m plus n. Diagrammatically I am showing this. In this case, one diagram is there, one line segment is there. The line segment P is first point P is joining the 2 points x1 comma y1, and Q is there. Here x2 comma y2 is there. Division point or L here will come. M is to N ratio. M parts, this side is M parts, and that is N parts. At a time, how to find out coordinates of or means we have to apply this formula: mx2 plus nx1 whole dividing by m plus n, comma, m by 2 plus ny1 whole dividing by m plus n. This formula is called internal section formula. Internal section formula, this is. This formula is called the internal section formula. If instead of plus external formula, in case of internal, the division point lies between P and Q. In case of external, the division point will come from outside. I will show now external formula in which way we are taking now. Second, the external formula. The external formula of division points is given by or is equal to mx2 minus nx1 whole dividing by m minus n, comma, m y2 minus n by 1 whole dividing by m minus n here. The division point will come outside here. See here, the line segment here. Here P is there. P is x1 comma y1 here. Here Q is there. Here one point Q is there. Here x2 comma y2 is there. Division point from outside. Here division point will here come. Total ratio m, and this ratio is n, like this. Up to it is m. And here n ratios. Like that, the division point will come from outside. It is going to divide the line segment from outside. Then we are calling this formula is external section formula. This formula is internal section formula. Divides means we are taking that formula here. If there is no any ratio, third point is third formula here. The midpoint of the line segment. The midpoint of the line segment of the line segments. The midpoint of the line segment PQ is given by m is equal to x1 plus x2 whole dividing by 2, comma y1 plus y2 whole dividing by 2 here. So diagrammatically it divides the two equal parts. Here P is there and here Q is there. P is x1 comma y1 considered here and Q is x2 comma y2 considered. It divides the two equal parts here on equal parts. Then equal parts means we are calling division point is midpoint. It's some ratio. This side is some point, some parts, and this side is some parts means it is internal or external. Based on line the division point, we are going to using a section formula here. If the division point lies between, that means we are going to using internal. If the division point lies outside means we are going to using external. Like those formulas we are going to using to solve some different types of problems in case of division or in case of section formula. Like that today I told one important theorem, distance between the 2 points. Same time I have given some important points also here. Next class onwards I will give some more important points under the notes. What are the conditions to show collinear points, and what does how we are going to find the area of triangle, how we are going to telling the points are collinear with respect to area of triangle, and after that I'll start slope of a line segment, how we are going to giving definition of slope of line segment, how we are going to finding slope formula with respect to diagrammatically or geometrically. We'll discuss about all these on next class. Thank you very much.